Okay, let's start. So welcome to the Big Data virtual chapter. Today we have a session with Scott Shaw as the speaker is Hive SQL on Hadoop. My name is Paco Gonzalez and I'm the past Big Data virtual chapter leader, and I will also be the moderator for this session. Now I see it. Thank you. Also, please remember that you can ask questions. I will read the questions at the end of the session. Go ahead, Scott. Thank you.
Okay, thanks. So as you mentioned, there is a book hopefully coming out in May, so working on it. And I'm not doing it alone. There are two other folks that are helping me, Anchor, who's a solutions engineer at Hortonworks out of London, and also Cindy Gross. So I want to give my kudos to them. The other thing I want to point out too is I will be speaking next month at the PASS virtualization virtual chapter on virtualization. And I will be talking about virtualizing Hadoop. So I was going to do it this month, but had some conflict, so I want to give shout out to David Klee for filling in at the last moment. So feel free to join me next month. All right, so this is the quick overview of the agenda. We're going to talk about Hive. We're going to discuss what is Hive, why Hive, and what's next. And for me, the most important thing I want to make sure we get to and have time is a quick demo. So if I rush through some slides, I'm sorry, but it's going to mostly probably be because I want to try to get to the demo before we run out of time, and also want to leave enough time for questions because there usually tends to be a lot of questions around this. So what is Hive? I want to first give a errata to the title of this session where it says SQL on Hadoop. It should say SQL in Hadoop. I don't know of a single customer that I've engaged with that is not running Hive on HDFS. It is the de facto standard for SQL in Hadoop. And it isn't just some meta layer on top of or some add-on to HDFS. It is now integral into the whole Hadoop open source distribution and key in deriving any kind of analytics from HDFS. And we'll talk a little bit more about how that's possible and kind of what it looks like. So it is the standard SQL interface to data stored in Hadoop. It is how you schematize data on read in HDFS. It is shipped in every distribution, so you will find it in both the Hortonworks distribution and others. It is 100% open source. It is proven to scale to petabytes level for both batch and interactive queries. It is growing more and more with each release into parity with what we'd consider ANSI SQL. So we'll talk about the next release, which adds even more functionalities to SQL. So the idea is that if you already know SQL and you're familiar with Transact SQL or the Oracle SQL or MySQL type SQL, Hive will be a very quick way to get ramped up and to understand and start using Hadoop quickly, using the skill set you already have. In addition, Hive is, and more specifically HCatalog, is compatible with your existing BI tools. So anything with an ODBC or JDBC connector is compatible with Hive and can connect into the schema that you create within HCatalog. Hive was originally created by Facebook, and the idea behind Hive was to abstract away MapReduce from business analysts. Obviously, Facebook had a problem. They realized that they didn't need, they couldn't have an army of Java developers as business analysts, and most of their business analysts didn't know Java. In addition, SQL is one of the oldest analytical querying tools, running on I think about 35 years. So it is the traditional language of relational systems. So it made sense that when you want to do analytics against HDFS, that SQL would be the path to doing that for quick adoption. And obviously it runs on massive scale, 300 plus petabytes, 100,000 Hive queries per day. So Hive essentially is formed of a few components. There is, and we're not going to dive too deep into all of these. There is the Hive Server 2, which is a thrift service that allows you to have multiple clients connecting into the same Hive infrastructure. There are Hive drivers. There are compilers and optimizers within Hive. So these are similar to what you would think of as a SQL query engine. We are developing additional query engines, more cost-based optimizers. For instance, Optic is in the roadmap, which will be much more familiar to your, to the relational world. There's a Hive executor that executes the plan created by the compiler, and then there's the Hive Metastore, which is actually it's your schema, and it's essentially the metadata about your data and your schemas, your traditional tables and columns and information like that. That's actually stored in a relational system that ships with the distribution. Usually it's a MySQL. It could also be an Oracle database, as well as a Derby database. This is a high-level overview of the component architecture, and this is where we see, as a Hive user, you would connect through a choice of entry points, either like a command line interface or maybe through JDBC or ODBC using Tableau or Power BI or something similar. You can also go through a web UI like Hue, and then there's the Beehive that connects through your Hive Server Server 2. There's Thrift Server there, Hive Metastore, and then your Hive driver, which is your compiler, and underneath it will run MapReduce or TES against your nodes. So basically, what is Hive? So Hive is a data abstraction layer. So in traditional SQL, you have an ETL process that schematizes your data on write as it's placed into a relational system. What Hive does is Hive is a schema on read functionality where you create your schema against the raw data in HDFS. And you can create a number, and there's a number of abstraction layers in Hive that are very familiar to traditional SQL, including the idea, the abstract idea of a database, as well as multiple tables that can exist within that database. You can partition the data, partition by date, just like you would in a traditional relational system. And then within each partition, you can also create multiple buckets for performance purposes. So this should all look very familiar. The difference is that the raw data, this is all an abstraction layer on top of the raw data. So the raw data never changes within HDFS, and it maintains immutability. And this is a sample SQL query that we see with Hive. So again, this should be very familiar to anybody that already knows SQL. So this is a select statement from a table where with predicates, group bys, halvings, and then clusters and sort by. Some of the differences we'll see with some of the table with the DDL commands is the type of tables you create. For example, like an ORC stored file, or how you need to define the type of file that you're selecting from, whether it's a comma delimited or a JSON or an XML file. We probably won't be able to get too much into those details here, but just know that SQL Hive is very flexible and can work with a multitude of different data types or data file types. I just want to point out that if you want some experience with Hive, there are some great tutorials in our sandbox. I strongly recommend grabbing the sandbox from our website, downloading it into a VM, and begin using Hive right away. There's some tutorials that will get you started. It's very easy, and it's actually a lot of fun. So why Hive? What's the value of Hive? Well, what we've seen, and we've talked about this in previous webinars, is what we're seeing a change in data requirements, new data types coming in. traditional systems built off relational systems, relational sources into relational type data warehouses, and then you run traditional data analytics against that. But then once you start introducing different types of data structures, server log, sentiment data, you increase the complexity of that traditional system. So what Hive now allows you to do is it scales. It can scale and allow you to read and process those alternate data types as you would in your traditional system. So if it's a server log or a sentiment log or clickstream or even emails, you can still run your same SQL queries against those different document types. That way you leverage the existing skill sets within your organization and you get a much faster time to adoption and actual insights. And not only that, but you can begin to store all these different types into a single location within HDFS, which will allow you to scale both your storage and your compute. And then Hive will run on top of it. And every time you create a table in Hive, you're creating a object, a hcatalog object. It used to be that hcatalog and Hive were separate projects, but now they've been merged into one. So when you create a Hive table, you are in fact creating an hcatalog object. And that hcatalog object can be accessed with your existing analytical tools. Anything, basically anything with an ODBC or JDBC driver. So that includes any of your, any ETL tools, as well as things like MicroStrategy, Tableau, and Power BI. And because Hive runs on HDFS, it allows you to store more data at lower cost. So what we sometimes suggest to our customers, and traditionally with your data warehouse, is most of the time users analyzing data on a data warehouse are only looking at about 6 months worth of data. So why store more than that on expensive data warehouse infrastructure? So what we suggest is moving some of that data using a tool like Scoop into HDFS and then running more trending and long-term analytics using Hive against that deeper data set. Hive is also excellent for ETL offload. So one of the goals with Hive is to try to have parity with all the SQL syntaxes that you would traditionally have in your ETL process. And this would allow you then to port over ETL into HDFS and use HDFS as your staging area using Hive and offload some of that expensive ETL processing from your expensive data warehouse infrastructure. Here are some typical Hive stories. They're all around both development of new business insights due to being able to retain more data and also mashing data together, as well as flexible data agility, the ability to ramp up very quickly because since you're not changing the underlying data and you're just creating a meta layer on top of your data, you can quickly adapt and change your data. There isn't the tight data type integration that you get in your traditional data warehouse, such as foreign keys and tightly set data types. So in summary, Hive is extremely scalable and very mature. It's one of the oldest SQL on Hadoop implementations out there. And it is one tool for all your SQL workloads, very flexible. It is 100% open source. Lots of companies integrate with Hive. Third-party analytic tools integrate with Hive, as well as the most BI tools support. So it is the de facto SQL in Hadoop solution. So let's talk briefly about what's in the process. So earlier in the year, there was a Stinger.next initiative which was delivered in our HDP 2.1. The purpose around the Stinger initiative was to make Hive more interactive. So the original Hive implementation, as mentioned, ran on MapReduce, and MapReduce is a batch processing language. So we still had some of the limitations that in Hive that came with batch processing. So normal business analysts would run SQL queries, but the results would be batch and would take a long time to process. Granted, you might be querying terabytes of data, but you would still not get that ad hoc querying feel that you're used to in your relational systems. So the Stinger initiative was a concerted effort to bring performance improvement into the Hive ecosystem. And it was a joint effort. We had 145 developers from 45 companies produce 392,000 lines of Java code, including Microsoft. Microsoft actually helped develop the ORC file format. And what came out of it was a query planner, a updated query planner in Hive, as well as an execution engine called TES, and additional file formats called ORC file, which there was, prior to Stinger, there was a RC file, and so ORC stands for Optimized RC file. And so this was all delivered in HDP 2.1, which came out in, I believe, last June. So as we look forward, there is now an effort called Stinger.next to further increase the scale or the performance and functionality of Hive. And one of the things that I think a lot of people are most excited about is the concept of ACID transactions in Hive. And this will be available in HTTP 2.2, which is coming out very soon, within the next couple of weeks, I believe. So what this will allow is the insert, update, and delete of data within Hive. So this introduces new ways of processing data. So think of some things like slowly changing dimensions. Like I mentioned before, we're trying to get parity with your traditional ETL processes, so you can offload ETL in mass onto HDFS. And so something that needed to be done is something like introducing the concept of slowly changing dimensions in Hive, as well as things like merging or just inserting data, change data into your schema. There's also things called the cost-based optimizer, and the idea of temporary tables that are coming up, and that's just phase one. So there's two other phases that are going to be introduced within the next few months into Hive. So lots of changes coming up. So again, we're moving Hive into a interactive SQL. So we're looking for that interactive ad hoc feel for Hive. Now, keep in mind that the intention of Hive is in the development in Hive is not to replace transactional processing. You're not going to use Hive for your e-commerce, e-cart type activity. So this is still an analytic tool. So we're not going to see complete parity with ANSI SQL. So for instance, you're not going to see triggers in Hive, because traditionally you wouldn't have triggers in a data warehouse. So that's not the intention. The intention is to make Hive the de facto tool for analytics in Hadoop. And in order to do that, there has to be a focus on speed, scale, as well as a broad range of SQL semantics specifically for analytic applications. So this gives a quick roadmap. So right now, coming out in our next release will be Hive 14 or .14. I just called Hive 14, and that will include ACID transactions. So we continue to develop and refine the system, the project completely in open source. This gives a further roadmap. So second half of 2015, we'll also begin seeing, so one interest that people ought to have, first half of 2015, we're looking at Hive and Spark machine learning integration, which I think a lot of people will be excited about. Second half of 2015, some interesting things around materialized views, non-equal joins, things like rollbacks and commits, as well as cross-geo queries. So that will allow you to run a single query that will reach multiple data centers. So that will be in the second half of 2015. So this just gives you a good idea of what to look forward to in the future. So let's dive down a little bit into transactions and how that's being approached. So again, transactions will allow modifications, insert updates and deletes. And the use cases for this is around reporting with analytics. So maybe you need to offload, so that's more like the ad hoc type reporting, but maybe you need to make some modifications to the data, maybe some data cleansing, things of that nature for the reporting. I think what's really going to be beneficial for a lot of users is the offloading of operational reporting. So we've all, if you've worked in the relational systems for a while, you know how devastating operational reporting can be on a transactional system. So what we're working on is being able to move the transactional data, replicate that transactional data into HDFS with Hive schemas, and then you can begin running your reporting, your SQL reportings directly off HDFS and offload that from your transactional systems, which should free up some valuable resources in that system. And that may involve periodic bulk inserts, every 5 to 30 minutes. And many times with operational reporting, it's not necessary to have real-time data completely in sync with your transactional systems. It can tolerate some lag. But if you needed real time, then there's also the introduction of Hive streaming, which allows you to stream data in real time directly into Hive schemas, and so users would be able to see those changes immediately. But we will not be replacing your operational transactional, your OLTP databases, meaning that for those transactional systems that do random and small insert updates and deletes and very frequent updates or deletes with hundreds or thousands of users, that's not the intention of Hive. So how does it work behind the scenes? I know a lot of people are curious about this. So what it will actually do is so ACID transactions only work with ORC files or ORC files. So when you insert, update, or delete a file, it'll actually create a delta file. And for each insert, up, and delete, it'll create an additional delta file. Now periodically they'll run a process called a compactor, and you can have a minor compaction or a major compaction. A minor compaction will compact all your delta files into a single file, while a major compaction will actually merge all your delta files into your optimized ORC file. And that's basically what it's doing behind the scenes. It's a versioning process. So you're still maintaining the raw data within HDFS. You're just changing the ORC file. Additionally, there is the introduction of LLAP, which stands for Long Live in Process. This is a process, a daemon process that runs on the individual nodes near the data, and it will do localized query optimization at the node level. It's an optional process or daemon that you can run per node. It will also provide some data caching mechanisms. So you can start processing queries, query fragments in memory as opposed to on disk in HDFS. And it will integrate with Yarn for resource management. Also in the works is richer analytics, so things like materialized views. We talk about cross-geo queries, machine learning, integration with Spark, and some other features. And there's the three-phase approach. So look for the introduction of all these enhancements in the second half of 2015. This is a quick summary of some of the SQL that's being developed or has been developed. So the gray boxes is the Hive 14, which includes the insert, update, and deletes. The roadmap for the first half of 2015 include non-equijoins as well as union and intersects. So you can see here just in the past 6 months or so since Hive 13, there's been quite a bit of work done to really make Hive a enterprise class SQL solution for Hadoop. Another introduction is, which was pretty large, is the introduction of the char data type too. It used to only be string, but there were some issues around, trailing white space that would cause some data issues. So now the introduction of char in Hive 13 fixed that. So the open source community is working hard to ramp up and make Hive the best it can be. So that brings me to a quick demo. So what I'm going to do is, let me minimize this. Hopefully everybody can see my screen. I'm going to log in. I have the sandbox running, and I'm going to log into Embari. I'll make this full screen. So just to show you Embari, so Embari is the management console, and this is where you would configure Hive, and you should see Hive over here. Within here, you have the different components that we talked about. Here, it's running a MySQL server for the Metastore. Here's your Hive Server 2, as well as your config files. So if you needed to config TES as the database engine, this is where you would do it. You configure your database name and your database username. Here are your database choices for your Metastore. So this is just standard config. And this is running the 2.2 tech preview and Embari 1.7. So what we'll do real quick is we're going to log into Hue. All right, this is the Hue interface in our distribution. And we'll go to File Browser. What I've done is I've created a folder called Hive Demo, and then a folder under that called Movies, and I've uploaded a file here called movies.dat. And basically what movies.dat is it's a colon delimited file. So it has an ID, it has the name of the movie and the date, and then it has the genre of the movie. And it's just a flat file. It's just a text file within HDFS. Actually, I'm going to drop these. We're going to recreate them. Yep. So what we're looking at here is hcatalog. Just be aware I'm running this on a sandbox with a node of 1, so there's no parallelism. So excuse it if it's a little slow. It's going to be slow. All right, so that drops it. So what that probably did is that dropped the file. So let's go back into here. Yep, and I'm going to create another folder, and I'm going to name it. Oh, what happened there? What just happened? Got any problem? No. Sorry, guys. All right, there we go. We'll create movies. Submit, and then what we'll do is we'll just upload a file. Select the file, and here's my movies.dat file. Okay, and there it is. It's uploaded into HDFS. Now if we go into, this is the command line interface, and I'm in a directory called Hive Demo. If we look at that, I have some Hive QL. Now you can name these. These are scripts, so you can name these whatever you want. Traditionally, the standard naming convention is HQL. And if we look at these, let's look at the movies HQL script. It's nothing major. It's a create table statement where it identifies the ID as a string, the title as a string, genre as a string, and it's row format delimited, and it tells it that the fields are terminated by a colon, and then it gives the location of the file. And if we run this, to run a Hive file inline, you type hive-f and then the name of the file. So hive-f movies.hql. This will take about 7 seconds to run. So it's going to parse that. It's going to parse that file. It's actually going to create this table within the metastore, and then when you access that table, it'll parse that file based off that definition. All right, 7.4 seconds. So now if I do a select star from movies, and I'll just limit it to 10. Oh, have to be in Hive. That would help. I could also do this from Hue, from the Hue interface. They'll get going here in just a second. Again, your real-world performance will be much better, trust me. All right, select star from movies, limit 10, and it'll run a map reduce. And there it is. So there's your table. So the data isn't in the table, it's just a view on top of the raw data file. So now what we're going to do is we're going to create a orc table. And we're going to do this using the movies underscore orc HQL. If we look at this, we cat it. It has the same create table statement, except it's stored as an ORC file. And so let's just go ahead and run this. And this is going to create an empty table, but the table definition will be stored as ORC. Now what an ORC file does is it basically creates stripes of information which contain metadata about the data in the file. So it'll pre-aggregate some data, it'll do summations of the data, it'll also give you kind of a partitioning of the data so that when you access it through, so when you access the data, if you do a select star from a orc file table and it has where predicates, it'll access the data faster. It's almost like an index. All right, so that created an empty orc table. So now what we're going to do is we're going to load that table, the orc table, with the data from our other table. And it's insert into table movies orc select star from movies. That should be pretty familiar to anybody that knows SQL. So let's do that, and we'll just do load movies.org. So the combination of using TES as well as ORC files will greatly increase, as well as multiple nodes, will greatly increase your performance of Hive. This is why when we do pilots with customers, we always make sure that there's an understanding of what you are piloting, whether you're piloting performance or you're piloting feasibility or usability. So it's running a map job. Loading the data in there, 28 seconds. And if we do, let's go back into Hive. What we can see over here now, if we look at hCatalog, now we'll see the two tables here. And I didn't show this before, but there's actually, if we look here, the tables when we created the tables, it created it in the default database. So if you look here, loading data table default.movies.org. This default is the database. And so you could have created a database called movies and loaded it into the movies database. If we do a select star from movies_org, limit 10, let's do that. Since it's a select star, there's really not much optimization we can do on it. Same with SQL, right? And there you go. There's your data. Now keep in mind real quick that if we delete the tables, it will delete the data from HDFS. We could have changed that behavior if we created the table as an external table. Then the data would always reside in HDFS independent of your schema. So if you delete your schema, the data would still remain in HDFS. Just a small thing to keep in mind. And that's, should be able to browse the data here too within, oh, no, sorry. I figured it would do that. Some with ASCII code. But that's Hive in a nutshell right there. Obviously, that's a very simple example, and there's a lot of other options. So I didn't show things like loading XML or loading JSON files. You could have that tab delimited or colon delimited data in the same table as JSON data. I also didn't show any joins. So if there was another like there's a ratings file that I didn't load, but that you could have joined that to the movie ID to get to have a join query. So lots of options and cool stuff. So that's basically all I have. Hopefully it was helpful. Now let's take some time for questions.